If you've been here a while, you know this channel is not about reviewing products, but today I'm gonna make an exception. I got this new welder from YesWelder, and I'm gonna review it because I get so many questions about, hey, what machine do you recommend? Why are TIG machines so expensive? Do I have to get the one you have? You know, I teach a welding course both in person and online, and people ask all the time, like, what do you recommend? Is an entry-level machine okay? And this is something that I want to check out. I'm going to give my honest opinion on it. This machine does it all. It is a TIG welder, MIG welder, and plasma cutter all in the same machine. So I'm really excited to try it out, and fingers crossed it works well. If you look at some 200 videos I've done, about 80% of them required welding for something or the other, whether it was building a tool, repairing a part. I did a lot of fabrication and custom modifications to my car, and nothing allows that like a welder. Let's see what's in the box. And just so you guys are aware, this is a sponsored video. I did not buy this myself. I was given this machine to do an honest evaluation, which I will do. There's always a box inside a box. Another box inside the box. Okay. This is not their first welder. This is a new product by them, but they've had products in the market for a while. One thing I like from the start is the clamp and the positive, negative, and the torch. Everything is removable. The Miller machine I have, it's not as easy to remove the stuff. So as you take it places, you can just unconnect everything and put it on a shelf. I kind of like that. And this machine is both 110 and 220. So it's a simple adapter here. I'm going to use it in 220 mode. You can use it in 110 mode. It just has a little bit less output capacity. This is the MIG side of things. It takes the larger, I think it's a 10-pound spool. That's good news because I can just borrow this wire out of my Miller machine and we'll put it in the new welder. More goodies. This is the MIG torch with the standard, trigger. Okay, the nozzle unscrews. Mine on the other one, I'm used to just pulling it off. Seems good. It's got a little thicker handle than my other welder, so it feels a little different in my hand, but it's just a little bit bigger. So this is my Miller, and I can kind of close my hand around it. This one here it can't quite close it, but the trigger position is very similar. So I don't see any problem with using this one. Okay, and here's the TIG torch. This is the 17 size torch. This is the same size I'm used to using. And it did come with a couple different variations on nozzles and stuff, which is great. Some of those are way too small. So like I said, it's also a plasma cutter. So this has a little safety on it. You just put your finger underneath there and pull. So that doesn't bother me. The reason for the safety, and this has happened to me before, when you set your torch down, it sometimes will fire and it shoots out flames. So you don't want this to just contact the table. These are some of the plasma cutter tips. Those are consumable. They do wear out after a while. So that's everything in the box. Let's hook it up. I'm gonna set it up for TIG first. This is what they call DC negative. So this electrode has to go to the negative. And then the ground clamp is positive, which is counterintuitive, but that's the way TIG welding works. It's not unique to this machine. Consequently, that's why if you're working on your car, you should always disconnect both sides of the battery because you are putting power into the negative and that can damage electronics. So that's a little tip aside from this machine. Attach that to the table. And then this is the gas connection. This is coming right from my tank. This is just a little adapter here to make a connection. And then the gas is gonna flow through the hose and out to the torch. I'll show you how to turn that on in a second. But let me show you my gas setup. So we follow this hose, it's going down underneath here, over to this bottle. This bottle is 100% argon, and it has a regulator there on top. And it's set for about 15 cubic feet per hour when the gas is flowing. It's important to know what it is as it's flowing. With it flowing, this is about 14. I'm gonna turn the machine on, switches here in the back. And if I just go to the home screen, you select lift TIG. I'll explain the lift part here in a second. You hit select. Input is 220 volts, and I'm gonna reduce the current to about 35 or something like that, 34. Really easy to select. This is telling you here that the ground is positive. There's a little plus here. Positive ground, negative electrode. Okay, here's the torch, it's set up. I'm using, like I said, the 16th inch tungsten. It's sticking out about 3/16 of an inch, maybe 5/16, but that's the stick out length. The tungsten is sharpened, and this is the gas control. So when you open this up, gas will flow. I don't know if you can hear that. So I'm in control of the gas. I can control, before I start welding, I'm going to open it. I'm gonna weld. As soon as I'm done welding, I'm gonna close it. So it's my job to turn the gas on and off with this finger control. You'll also notice I did not connect an amp control to the machine. This is what they call lift start. So you don't use a pedal to control the current. Basically, as soon as you make contact with the metal, it's going to tell the machine it's ready. And then when you lift it off the metal, that's when the arc starts. So you're not using a pedal. So you might think, oh, it's gonna be easier without the pedal. Well, yeah, you don't have to use your foot, but it also means you don't have variable control on the output current of the electrode. So whatever you set on the machine, 35 amps, as soon as you lift the tungsten, you're gonna get 35 amps, like it or not. So it's a little bit of a simplification, but it also removes some of the control. I don't have amp control and I don't have gas control. It's all sort of done manually. Okay, and because I'm an automotive guy, one of the big uses of a TIG machine is to weld thin sheet metal. And that's what this is. This is 18 gauge metal. Actually, it's 20 gauge metal. This is about as thin as you'd get. So I thought we would start with this. Of course, it'll do thicker metal, but because I do so much auto body repair, I want to make sure it works on thin metal. So to prep the metal, I'm just going to clamp it together on the edges. This is to simulate what it would be like on a car. Putting in a patch panel. This is a butt weld. We can try some other welds too. But I got it clamped together. This gap is almost equivalent to the metal thickness. 20 gauge is about 30 thousandths of an inch, and that's probably about a 30 thousandths inch of a gap. I can get my fingernail in there. So this is going to be really difficult to weld, and I just want to try. I'm also going to lift it up off the table because when you're working on your car, you're not going to have the pieces. You're not going to have the pieces laying on a table either. This is a lot easier. So I'm going to do it here in midair. Okay, the filler material I'm using is also thin wire. This is 35 thousandths MIG wire, and it's been straightened. It's about the same as the width of the gap there. And I'm also got something to protect my arm from UV rays, and also I'm using a thicker latex glove here to hold my filler hand. And then I'm not going to wear a glove at all on this hand because this is the one that I'm using to control the gas, and I really can't operate it with the glove on. I got to turn the gas on, so I hear gas flowing. Grab the filler and make contact. And then break it. Okay, and what happened, as soon as I started welding, it pulls the metal together, which is kind of a nice thing. And if you look at the back side, you know, it's welded all the way through. And it does shrink the metal, so it pulls it in tighter. And if I unclamp it, you can see it's already distorted it just a little bit. Yeah, I just picked this up after welding it. It's still not that hot, even though they're small pieces. This is a 20 gauge, 1/16 inch tungsten. I did reduce the current down to 27 amps, and it is using the 035 filler wire. And the initial gap was probably about 20 to 30 thousandths of an inch. I'm gonna do this again, moving the camera down with the lens on it, so you can see exactly what I'm doing. Okay, this is a real quick demo on these two 20 gauge pieces, and I didn't spend a lot of time on it, perfecting it and adjusting it, but I thought it did okay. The lift arc is okay. You have to, start it a little bit off the seam and then drag the puddle over on top of the seam and be ready to fill right away. Because if you don't have the filler there, it's just gonna blow a hole in the metal. And it takes a little bit of extra practice, a little bit of extra skill. I kind of like the high frequency start. That's available on much more expensive machines. But can you do it with lift arc? I mean, you absolutely can. This would be a good entry-level machine if you're not sure you want TIG, but if it kind of came with the welder, you might be more encouraged to try it. And that's where I think the benefit of this welder is. You don't have current control, but you can still do 20 gauge metal. You just have to keep your travel speed up. You have to be ready with the filler. The filler actually cools the workpiece. And those things just take a little bit of practice. So even though it doesn't have as much control as my miller, it still works. And I think that's the important thing to know. I would have preferred the thinner tungsten. Usually I use 040 tungsten. This torch would absolutely accept the collet. I just didn't use it because the machine didn't come with it. But you can go a little thinner on the tungsten, and you can also change the settings. It might make sense to start a little lower than 27 amps because you don't have full control. 27 amps comes right out the gate. So you might want to start at like 22 and then just move slower. That'll make the heat zone a little wider. You'll have a little bit more distortion, but you have to compromise when you don't have the foot pedal control. The other disadvantage of the lift arc is you're probably going to have to sharpen your tungsten a little more often. So when you start the tungsten on the metal, you're eroding a little bit of the tungsten and you don't get a super clean arc. I made a mistake when I was dragging the puddle across. I accidentally contacted the filler to the electrode and fouled it up a little bit. So that was my fault. But you will have to sharpen your tungsten a little more often when you use lift arc because you're actually contaminating the tungsten every time you lift it off the workpiece, if that makes sense. But I was able to get a good arc. And also the gas control, you got to remember to turn it off. So you might be sharpening the tungsten more, you might be using a little bit more gas. This is 1/8 inch metal, and I'm going to just do probably some kind of, fillet weld or something. I make a lot of brackets, and so 1/8 inch is pretty typical for a car. So I'm going to change the tungsten to something a little thicker. I'm going to go with the 1/8 inch tungsten, and that's appropriate for this, or this is 3/32, I think. That's appropriate for this metal thickness. Okay, I got this piece clamped to the table, so I'm gonna start the arc on that side. See how we do. Okay, just need a little more current to going too slow. Okay, maybe now we're ready. Oops, forgot to turn the gas on. Got to resharpen the tungsten now. Okay, this was not rehearsed, and I definitely made some mistakes on this. Got started, the filler wasn't the right size. I forgot to turn the gas on, so you can see the huge porosity there and the mistake I made. And then right here was welding pretty well. And then right here at the end, I could see it burning through. Normally I would let off the pedal because you do a little bit fewer amps on the end, but I might have had the amp set too high now, because I had to just add more filler to prevent this from just getting eroded away. So overall, I'm just kind of showing you the machine will definitely do it. If I was doing this for myself, I would have done some practice pieces and get the machine dialed in a little bit better, but it absolutely will work. All right, now it's time to set up the MIG portion of the machine. And if you have any questions about the TIG, just let me know in the comments below. I'll be happy to try to answer them. My expertise is mostly in thin sheet metal, and that's why I gave it that test. It's a pretty hard test. 20 gauge is thin, very thin. Most metal on cars is between 18 and, it depends on the kind of car, but most of it's like 18 gauge, which is thicker than 20 gauge. And I had a poor fitting panels, and I did it on small pieces with air underneath it, and with an entry-level machine. That's pretty much as hard as it gets. So if you have questions, I'd be happy to answer. But now let's go over the MIG. MIG with gas, select. So when you pull the trigger, it feeds the wire, but it moves pretty slow. But if you hold the button down, it'll feed it much quicker. There we go. And put the tip on. Okay, I'm using the gas bottle on my other welder. I just have it going right into the back of the YesWelder. So same thing, this is regulated here, so turn it on. This is currently set to about 15 or 20 when it's running. 75% argon, 25% carbon dioxide. There is a setting here for 100% argon, but for steel, I just use the 75%. So I need to do select that, and then you can move to, that's this one, 75% argon. And thickness, I'm gonna do, let's see, 10 gauge. That's about 1/8 inch. Burn back, we can give it a little bit of burn back. Controls the stick out length, and everything else is kind of set for us. This knob allows you to change the voltage within a small range. Current is 100 amps, and the speed is kind of programmed by the metal thickness. So I'm going to leave it at that and just give it a try. We'll start here at the middle. It's pretty good. I'm going to try again in this little valley right here. I turned the voltage up slightly, so let's see what happens. I think you can hear that one sounded a little different, and it's just a matter of getting the settings right. I think that was probably a little too much voltage. But the weld is, you know, pretty flat, not bad at all. So let's go back to that really difficult welding we did earlier, 20 gauge. I'm gonna give it the same little gap. And I'll set it to a new setting for 20 gauge. Actually, there is no setting for 20 gauge, only goes down to 18. So we'll do the best we can. That's not what I expected. Okay, that does not sound right. Going up in voltage. There's not enough wire speed. It's better. It's getting better. Okay, it did weld it. I don't like how tall the weld is. Probably continue to do some modifications on the settings. You know, if you look at this TIG weld, it's very flat. You look at this MIG weld, and it's really tall. But it did work. Let's look at the back. It did go through the back. And the settings I ended up with were quite a bit different than what the machine told me to use. I went all the way down on the voltage, minus 5, and then I was using 42 amps, which automatically sets the wire feed, 7.4 inches per minute. All right, now it's time for plasma cutter. And if you have any questions on MIG or any comments, leave them below. You know, my overall summary on the MIG is it works fine. MIG is a lot easier to use than TIG, but it doesn't mean it's better. So like I showed with the automotive sheet metal, yes, you can weld it, but there's way more porosity, there's way more grinding required. And then let's set up the plasma cutter, one of my other favorites. A little hard to tighten. This bezel's kind of in the way. It was in the way for the TIG machine too. So, but it works. You just gotta work with that. And we need a ground clamp. I think this one goes on here. This is the ground. Connect it to the table. And we'll use compressed air on the back. Let me show you that. And this is currently set to 5 bar. It doesn't have PSI. I don't know how much PSI that is, but generally on my other machine, I go up to like 80 or 60 or something like that. It does take a lot of air to run a plasma cutter. Hit home, go around the dial till you see plasma cutting, and then you hit select. I'm gonna go 30 amps on this. I've done this many times for brackets and stuff. This is a piece of 1/8" steel, and I just got a straight edge on there. We're just gonna cut it straight across. Every time you do plasma cutting, there is some slag on the back. I cut right through some previous welds. You know, this is what I use when I turn my machine on and purge the gas through it. So this is all just a bunch of bad welds. But if you want to knock the slag off, it's not that hard. Usually I just clamp it to the table. Clamp it up, and then I have this thing which just is like a slide hammer. So you're left with a pretty smooth cut. Right here, the torch got a little sideways because I was running over a weld bead, but it generally cuts pretty well. It's got a little bit of a bevel to it. This side has also got a little bit of a bevel to it. We'll knock those beads off. You don't even have to clamp it down most times. It just comes right off. But the cut is not 100% straight. It's just got, I don't know, maybe like a 5 or 10 degree bevel on it, but it does cut through it. And you know, normally you just hit this with a grinder or a file, and then you can weld it or bend it or do whatever you need to do. You don't need an air compressor this big, but it certainly would cut all day long with something like this. You just can't get by with one of those nail gun compressors or pancake compressors or whatever you call it. A lot of people will use an angle grinder and a cutoff disc. That's totally fine. My personal feeling is that the plasma cutter is better because you can cut straight lines, you can make templates and do curves and stuff, whereas this is just purely freehand. So the work comes out a little straighter with a plasma cutter, and these things, to be honest, are quite dangerous. These discs will separate and break apart, and you know, you don't want to get that in your stomach or your eye or anything like that. So I think plasma cutting is a little safer, and if you got the machine, you got the equipment, it just does quick work out of it. Plus, you can do probably up to 1/4 inch. You just got to move the torch a little slower, but it will go through it. So cutting through 1/4 inch on something like this is a nightmare. And actually, plasma cutter will cut aluminum too. It's just the same thing. You got to go a little slower, and it does leave the slag on the back, but it just knocks right off. So I like plasma cutter over these things. All right, I didn't show every little feature on the welder. You can go through and look at all the menu and memory settings, but I thought it worked pretty well. There's only a few things I would do differently. I think the power switch being on the rear is kind of cumbersome. It's hidden behind some hoses sometimes. A little hard to reach. I prefer it be here on the front. And also on the front, this plastic bezel kind of gets in the way of some of the 1/4 turn connectors. But all pretty minor things. When you turn it on and off, it doesn't revert right back to where you left off. So if you go to lunch, you come back, you turn it back on, you got to go through some more settings to kind of get back to where you were. I think there are some memory functions, but I didn't get into that. All small things. The end of the day is, can you get work done on your car with the entry-level machine or work in your workshop done? Yes, I think it works pretty well. Do you need to buy blue Miller or red Lincoln? I don't think so. The ability to put metal together is rarely due to the machine. It's mostly due to the welder. And this is what I prefer you do, is get something like this and get started. The machine is not going to limit you until you really get very, very proficient, or you want to do aluminum, or you want to do real thin metal and you'd rather have that pulse control or the foot pedal control. Those kind of things will come with time, but this is a great machine to get started. I think I showed that on TIG, which is my favorite, it is possible to do the lift start, get going with 20 gauge, and you just got to be careful on things like the edge. You got to really know how to adjust for your heat zone if you got to travel a little quicker or whatever. But it will work. I do like the high frequency start. I do like the variable pedal on my Miller. But like I said, that's a $2,500 machine, and it only is a TIG welder. This, I think they're offering for the next few weeks, I think they're offering it for like 500 bucks, which is pretty amazing. That's not its normal retail price, but if you look at the link in the description below, I think there's a page there. You'll see how long they're offering that $500 special. It's, I think, a pretty amazing deal. So thank you guys for watching. If you're wondering about my car, yeah, I did do work on my car this week and it was sanding. So I don't have a lot of footage on that because it's basically just me sanding, but the good news is it's all filled and sanded. It's ready for the base coat and clear coat. Actually a sealer coat next, base coat, clear coat, probably next week unless I get interrupted with something else interesting. But thanks again for being here. Thanks for checking out the Welder, and let me know if you decide to buy it.